This is your 3.3 note video, and we are doing proofs with parallel lines. It's really similar to what we did yesterday, but we have the converse. So let's just quickly talk about this. Remember the converse. So the conditional, if P then Q, and the converse is if Q then P. So basically we're doing the backwards, the switched around of what we did yesterday. So let's read one of these and I think you'll understand what I'm saying. So if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Yesterday we did the opposite of that. So here's our abbreviation. If corresponding angles are congruent, then we have parallel lines. So again, it's just the backwards order. So I'm going to go ahead and write the abbreviations for all of these. Then we're just going to get into some proofs, and we have to pick out which ones we're going to use. So if alternating interior angles are congruent, then we have parallel lines. Moving down the page, alternating exterior angles are congruent, then we have parallel lines. So same side interior angles, sum to 180, then we have parallel lines. And the last one, same side exterior angles, sum to 180, then we have parallel lines. So again, it's just going backwards, right? It's depending on what you're given. Are you given congruent angles so we know we have parallel lines? Or are you given parallel lines so that we can use our theorems? Either way, that's what we have to choose between. So with that in mind, and with the same things we did yesterday, let's go ahead and jump to some proofs. So I'm going to go ahead and draw my T proof. Okay, so I have my statements and my justifications. I'm going to go ahead and try to reason through this. Now, let's just look. I like to use colors to try to match what I have. So I have that 2, oops, that's not a highlighter. Let's go ahead and fix that. So I have that angle 2 is congruent to angle 4. And I want to prove 3 and 4. So I'm going to go ahead and 3 and 4. So in just looking at this, I know that I need to connect these. In order to connect 3 to 4. So if I can connect 2 to 3 and 4 to 3, right, then we should be able to go from there. Okay, so let's just jump in. We have some given statements. I know that L is parallel to M, and I know that angle 2 is congruent to angle 4. And those are all given. So that's where we start. I also know that angle 2 is congruent to angle 3, and those are alternate interior angles. So because I have parallel lines, my alternate interior angles are congruent. Now, I'm going to read this to you. I know that 2 is congruent to 4 and 2 is congruent to 3. So I can say that angle 3 is congruent to angle 4, and you could use substitution or transitive property. Okay, either one for this example works. Okay, that's it, right? 3 steps and I got to where I need to be. Let's go ahead and try the next one. So same thing. So I'm going to write down my given. L is parallel to M. And then I'm going to highlight what I'm proving. So 4 plus 7 have to equal 180. So 4 and 7, somehow I need to get those to equal 180. So I am going to look for things that are congruent that I can loop between. So I know that 4 and 7 have to equal 180. So I'm going to look for 4 and something else that equals 180. So I see that if I do 4 and 3, these are going to be a linear pair. And then I also see that these are corresponding. And so if I can say 3 and 4 are linear pairs and 3 is corresponding to 7, that means they're congruent, then I could substitute that in. Okay, so let's see how this kind of plays out. So my second step is going to be the measure of angle 4 plus the measure of angle 3 is equal to 180. And this is because we have a definition of linear pairs. And I know that angle 3 is congruent to angle 7 because they are corresponding angles. So because I have parallel lines, corresponding angles are congruent. And then I can use substitution. So I'm going to substitute 3 is equal to 7. So I'm going to substitute those in. So I get that the measure of angle 4 plus the measure of angle 7 is equal to 180 degrees. And again, I did substitution. Now, is this the only way you could go about it? No. Okay. You could go about it in different ways. So you could say 4 and 8. Okay, 4 and 8 are corresponding, and then 8 and 7 are a linear pair. Again, there's not one path to the proof, okay, but hopefully we can see how we're piecing these together. Okay. Again, I'm going to draw my T proof. So I'm given that L is parallel to M and A is parallel to B. So if you wanted to, you could go ahead and mark your lines parallel. You don't need to, though, as long as you keep that in mind that, yes, they are parallel. Okay, and again, I like to try to find where my connections are before I start my proof. So I am trying to show that 1 is congruent to 5. Okay, now there are a lot of numbers to pick from, but if I relate 1 to 2, 2 can't really relate to 4. It's like not really on the same transversal, or 5. So like that doesn't help. But if I connect 1 to 3, these are corresponding. And then if I connect 3 to 5, these are alternating exterior angles. So I think that that will get me congruent and congruent. So I should be able to get to my answer. So I'm going to start with 1 and 3. I'm going to state that angle 1 is congruent to angle 3. And again, because I have parallel lines, the corresponding angles are congruent. Now I'm going to connect 3 to 5. So angle 3 is congruent to angle 5. And because we have parallel lines, alternating exterior angles are congruent. So because 1 is congruent to 3 and 3 is congruent to 5, I can say that angle 1 is congruent to angle 5. And again, I could do substitution, but I'm going to go ahead and write the transitive property. Okay, again, either one will work. All right, so we're moving on. Number 4, 5, and 6. Again, just lots of proofs, lots of practice before you try it on your own. So we need to use this picture for all of the proofs. And so I'm going to try not to draw on it too much, but we should be okay. Let's jump to the first one. So again, I'm going to set up my proof quick. Okay, and starting with the given, so we have the measure of angle 2 plus the measure of angle 5 is equal to 180. And I want to prove that I have parallel lines, so that's important. And I'm just going to go ahead and look at this. So 2 and 5, those are not related by any of our theorems. So I need to figure out a way to get them related. Now, I don't have parallel lines, so I can't use any of our corresponding angles, same side interior, because I do not have parallel lines. So we have to use other things to get there. So it's really important that we are careful here. I'm going to use vertical angles here. I'm going to connect 2 and 3. So I'm going to go ahead and say angle 2 is congruent to angle 3 because they are vertical angle theorem. So because 2 and 3 are equal, I can substitute 3 and 5. So look at what happens here, okay? I know that 3 can equal 5 because 3 is equal to 2. I'm using substitution. So the measure of angle 3 plus the measure of angle 5 is equal to 180. And again, I used substitution. I cannot use same side interior because I don't know that the lines are parallel. I'm trying to prove that they're parallel. So because they equal 180, I can say A is parallel to B. And I can say that because we have same side interior angles that are congruent, or I'm sorry, they aren't congruent, they sum 180. Then I have parallel lines. So I'm using the converse because I'm proving parallel lines. So if you see that you are proving parallel lines, a note that you can make is use the converse. Okay, if you're proving parallel lines, you need to use the converse. Okay, let's go ahead and try some more. Statements, justifications. Okay. Again, starting with the givens, I know that A is parallel to B and angle 1 is congruent to angle 9. Okay, again, something that maybe you want to know, if you're given parallel lines, you can use the regular theorems. So if you're given parallel lines, you can use the regular theorems. If you're trying to prove parallel lines, you can only use the converse one time. Okay, so just something to keep in mind. If I look back at my picture, and I'm going to zoom out. Okay, if I look back at my picture and I erase from the previous problem, I know that 1 is congruent to 9. 1 is congruent to 9. I'm trying to prove that 8, change my colors here, is congruent to 10. Okay, now, here's what I'm thinking, okay? If 1 is equal to 9 and 1 is equal to 8, so I need to prove these are congruent because they're alternating exterior angles. These are congruent because they're vertical angle theorem. Then I can just substitute in. So that's my thought, is that I have alternate interior, vertical angles, and then I can just use substitution to make 8 and 10 congruent. Okay, let's see what happens. So it doesn't matter which one I go first. I'll just do angle 1. So angle 1 is congruent to angle 8. And this is, since we have parallel lines, alternating exterior angles are congruent. Then I can write angle 9 is congruent to angle 10, and that's our vertical angle theorem. So let me show you the substitution. 8 is equal to 1, so I can substitute it in. Okay? Then I can also substitute 9 is equal to 10, and I can substitute that in. So when I do this substitution, I can say angle 8 is congruent to angle 10, and that was substitution. Okay, you could also say that this is the transitive property, okay? And it's just a little bit longer. 1 is congruent to 9, 1 is congruent to 8. 9 is congruent to 10. Okay, again, it's just like a long chain. Substitution or transitive, either one will work. Okay, number 6. Okay, starting with the given, angle 4 is congruent to angle 11, and angle 5 is congruent to angle 12. Okay, so we have some good given information, and again, I'm going to zoom way out so we can see the picture, and then we can go from there. Okay, so let me erase what I had from the previous problem. Okay, so I know that 4 is congruent to 11, and I also know that 5 is congruent to 12. So this one is very similar to the last one. We still have vertical angles, okay, and again, I like to just make connections. So this is my vertical angle theorem. These are connected because they're alternate interior angles. And then I can use substitution, or I can use transitive. And then I want to pay attention to what I'm solving. So we do have to be a little bit careful. We are solving that lines are parallel. So if we're solving that lines are parallel, I need to use the converse. So something to keep in mind is if I have alternate interior angles, I'm probably going to use the converse of that in some way. Okay. So let's jump in and see what we know. So I'm going to go ahead and write my statement about vertical angles. I know that angle 11 is congruent to angle 12 because of our vertical angle theorem. Okay. My next step is I want to connect angles 5 and 4. So I know that 4 is congruent to 11 and 5 is congruent to 12. So 4, let me use my highlighter. 4 can substitute for 11. Okay, those are equal. 5 can substitute for 12 because those are congruent. And so I can go ahead and write this here. Angle 4 is congruent to angle 5. And again, substitution, property, or again, the transitive property, depending on which way you want to look. Okay, now I know that those are congruent. Now look at angle 4 and angle 5. If we go back to this picture, they're alternate interior angles, and we want to prove the lines are parallel. So I know that A is parallel to B because if I have alternating interior angles that are congruent, I must have parallel lines. That's the converse that we have to use there. Okay, we have 2 more examples, and we're done. Okay, so we're just gonna cruise through 2 more and call it good. So go ahead and set up are T-proof again. Okay, we can go ahead and write what we're given. A is parallel to B, and L is parallel to M. And again, those are given. So first step is out of the way. I'm going to highlight what we know. So I know we have parallel lines, which there's actually really nothing to highlight. But I'm going to go ahead and say these two are parallel. These two are parallel. Filling in, I'm trying to connect that 4 is congruent to 5. So again, I try to look through what angles are going to help me get there. Now I can connect 5 to 6, but then getting 6 to 4 is kind of difficult. And so I'm trying to piece together what I have. And I want to use as small amount of angles as possible. And I notice that if I can connect to 7, okay, I can do it 2 ways. These two are alternating interior angles. And these two, 5 and 7, are corresponding angles. So again, I'm looking at pieces of the puzzle. And then we should be good. Okay, so with this in mind, I'm just going to jump right in. And I'm going to start with, it doesn't matter. I'm going to start with 5 and 7, okay? So angle 5 is congruent to angle 7. And that is because I have parallel lines, so I know that corresponding angles are congruent. Okay, now I'm going to say angle 7 is congruent to angle 4. And again, because I have parallel lines, alternating interior angles are congruent. Looking at this, again, 5 is congruent to 7. 7 is congruent to 4. So we can say that angle 4 is congruent to angle 5. And again, we can use substitution. Or the transitive property. Okay, last one. Lots of proofs today, but lots of practice is good. So I'm going to draw my last T proof. And I'm going to start with my given. So L is parallel to M. And angle 1 is congruent to angle 7. I do want to point out we're proving that lines are parallel. So this one is a little bit tricky because we have 2 sets of parallel lines. However, if I'm proving parallel lines, I do need to use the converse at the end. But I do have these parallel lines up here. So depending on what I'm using, I can use the originals if it has to do with L being parallel to M. Okay, hopefully that makes sense. And we will zoom out to kind of see our connections here. Okay, so I'm going to erase what I have. I know L is parallel to M, so I'm going to erase these. I don't know that. And erase these. Okay. So I do know that angle 1 is congruent to 7. So 1 is congruent to 7. I'm trying to prove that A and B are parallel. So somewhere with A and B, I need to figure out like how to connect them with corresponding, alternating interior, alternating exterior, whatever it may be. So looking at this, I'm gonna maybe connect 1 to angle 5. So if I can connect these two, okay, because I know L and M are congruent. So if I connect those two using corresponding, then I can connect, okay, 1 and 7 because of the transitive property, and then I have congruent angles. Okay, so let's write that down. I know, step 2, that angle 5 is congruent to angle 7. And I know this because I have parallel lines, which tells me that corresponding angles are congruent. Okay, so watch this. I have 1 is congruent to 7, 7 is congruent to 5. So I know that angle 1 is congruent to angle 5. And again, substitution or transitive. Okay, and now because 1 and 5 are parallel, look at this. Or I'm sorry, because 1 and 5 are congruent, then A and B have to be parallel. Okay, so A is parallel to B, and it's because I have corresponding angles that are congruent. I have parallel lines for A and B. Okay, I know this is a lot. There are so many examples here. I really encourage you to think of proofs as a puzzle and figuring out how you can connect what you have to what you need and what properties go in between. We will practice more when we are together in class.